I'm still not satisfied with the Sony's vertical linearity. You could say that the egg-shaped test image that I saw was really bugging me. And I thought that I could do better. So I started reading up on diagnosticating that particular problem. And what I read in a few online articles is that if you have such a egg-shaped test image, that could be a symptom for a bad bias on the vertical driver transistor. Now, the vertical driver transistor is over here. This is the vertical drive transistor. Now, they do mention here and there that that typical egg-shaped image could also have an origin in a bad vertical output, which is the next transistor. But okay, I decided to see whether something could be wrong with the biasing of this transistor, and I measured these two resistances around its base. So one of the resistors is a 330 ohm, this one. The other, which is up here, is a 5100 ohm. Now, this one measures about 308 ohms. It's a bit low, but it's still, let's say, within spec. However, when I proceeded to measure this one, I only got up into the mega ohm values. So I was thinking that couldn't be right. Okay, I mean, I should get a value somewhere in the kilo ohm range, and preferably, of course, 5100 ohms. And the only type of value I get is way up in the mega ohms. So something is telling me that this resistor here, this 5.1 kilo ohms, might be open. So what I'm going to do is to unsolder this one and replace it. Unfortunately, a 5100 ohm doesn't exist. So a 5.1 kilo ohm, I think, is not a very is not a value which is very common. So I'll see what I can find in my stash of parts which is closest to this value. I might even cobble together a resistor so that I approach the value of 5100 ohms. Now, the 330 ohms, on the other hand, is very common, and I'm pretty certain I have one in stock. So, I'm going to replace both resistors, even though this one measures reasonably good. But since they are both attached to the same point on the PCB, and since I'm going to unsolder this point anyway, I thought it might not be a bad idea to replace them both at the same time. And when I'm ready replacing them, I will, of course, put the board back into the TV, into its bus connector, and try it out. If this doesn't work out, then there is still the bias resistor here of the vertical output transistor, which should be a 750 ohms. And it measures reasonably close to this value. I don't remember exactly, but I thought it was something like 760. So that's okay. And the 3 ohms, which is connected to its emitter, is 3.3 ohms. So that's still within the limit of 10%. So, well, I'll show you where that resistor is actually, that 5100 ohms. So if you take a look at the video board, which you see here, this transistor here is the vertical driver transistor. That one over there is the vertical output. Okay, so now the 5.1 kilo ohms is over there, this one there, and the 330 ohms is right next to it, so this one. So this one is the 330, that one is the 5100. So I'm going to replace these two and then see whether that fixes the vertical linear capacitors wired over the AC line, which are these two, so one here and one there. These two capacitors are each 200 nanofarad, and they tie up to the chassis of the Sony, and the other side of the capacitor goes, well, the other side of each capacitor goes to one side of the AC line, as you can tell for yourselves. Now, I'm pretty certain that the capacitors you see are not safety capacitors. So I reasoned that for safety's sake, I'd rather replace those capacitors and put a little bit more effort into it and be safe than not doing it, having a little bit less work, but always worrying that those capacitors might just give out and blow. Now, to be honest, it is quite a bit of work to reach them, because you see the capacitors are mounted on this contact plate, where you see this is a connector for the AC and the fuse below it. Now the capacitors I showed you on the schematic are at the back, and in fact you can see one of them over there stuck there. And well, I had to unscrew this metal plate from the main chassis body by unscrewing 3 screws, 2 at the front of the contact plate and 1 at the bottom, and it was screwed to this tab. Now, so I unscrewed them, and well, when I try to lift it, it simply won't budge. Yeah. So what I'll probably need to do is to unmount, or rather untie the safety switch, which you see here. This is actually a switch which is actuated if you use a 12-volt battery connector instead of the standard AC connector, which you see here. Yeah. And this little switch disconnects the AC input, or let's say the AC part, up to the bridge rectifier from the rest of the circuitry, so that the circuitry is fed directly from a 12-volt battery. Now anyway, I will need to probably unsolder these wires you see here, and that might allow me to lift the plate in that direction, and thus allowing me to work on those capacitors. So to replace those two capacitors turns out to be quite a bit of work. And there they are. These are the two 200 nanofarad capacitors which are tied to the AC lines. So now I need to unmount them and replace them by true safety capacitors. Unfortunately, mounting back the safety capacitors and the piece of the paneling back into its original position wasn't as easy as I thought it would be, because I had misjudged the original space between the selenium rectifier, which I had left in for, let's say, cosmetic purposes, and the filter choke, which is at the back. And so rather than to get rid of the selenium rectifier, I had to look through my stash for a standoff of the correct height to put between the selenium rectifier and the foot, which is built on top of the choke coil housing. And then I had to find, of course, a screw that would fit in place of the original screw, and which was longer to compensate for the standoff that is now between the choke filter top and the base of the selenium rectifier. And I found everything, and as you can tell for yourselves, it worked out fine. And you can see the yellow safety caps now gently located between, or gently squeezed I should say, between the base of the selenium rectifier and the top of the filter choke behind them. So it works out perfectly. Now, I also built into the AC circuit a NTC, which you see here. And I did that for two purposes. One is to limit the inrush current when the TV switches on. So initially there is a real rush of current going into the TV, and the NTC will limit that, of course. Secondly, I use a 10K NTC, and for a very specific reason, namely that the 10K NTC, which you see located here on top of the selenium, it's a rather small one, but it doesn't need to be a big one. When it drops to its working temperature, still has, say, somewhere between 200 and 300 ohms, and that seems to drop the value of the AC to around about 220, for which the transformer was originally designed. So now, even if the AC plug delivers 235 or thereabouts, the transformer gets a nice 220 volts. So it doesn't overheat actually. So that's really good. Now, remember I also checked the parts that were around the vertical output transistor and the vertical drive transistor. Now it turns out that the resistors themselves that are located around the let me see, I have the schematic here, so let me show you. So over there you see here right about here you see a 330 ohms and a 5100 ohms resistor, so 5.1K, 330 ohms. Now it turns out I did have a 5.1K in my stock, in my personal little stock, which is perfect. I didn't have to cobble together a resistor or anything. I just took it out of my stash. And the same thing for the 330. I had it available. So I replaced these two resistors with new metal oxide quarter watt resistors. Now, it turns out that the original resistors were still fairly close to their rated values. So the 330 is, I think, 308 ohms. The 5.1K is more like, well, I don't know, I don't remember exactly, but it was close to 5.1K. I think it was 5,700 or something like that, which, okay, it's a bit high, but it's not extremely bad. I've seen worse. Now, anyway, I replaced both with metal oxide ones. And then I also had a look at the schematic, and I noticed that the collector of the vertical output transistor is connected through to the contrast button, or potentiometer I should say, through a resistor and a capacitor. Now that capacitor is this one, okay, and it's a 200 nanofarad capacitor. Now I measured its value. It's pretty close to what it should be. I think it's more like 210 nano or something like that. So it's still within 10%. But I looked at one of its feet, and it doesn't look that nice. And it really looks like as if it's been oozing something. I don't know. In any case, I would not be surprised that the capacitor is leaky. So I replaced that one too. Now, I did switch on the TV afterwards, and I must say the quality of the vertical deflection was much better. It did improve, noticeably improve. And by tweaking the vertical bias, the vertical output bias, which you see here, I also I even managed to increase the symmetry of the picture even more. So even though right now you could hardly call the picture perfectly symmetrical, it looks much better. I think you can tell for yourselves that the symmetry of the picture is much better than what it was before. Okay, the circular pattern which I'm projecting onto the screen via an RF signal generator is, as you can tell, much more symmetrical. Okay, granted, it's still a little bit deformed, but compared to what it was originally, it has improved, markedly improved. So I really can't complain. My efforts did pay off. Now, weirdly enough, the picture is skewed more to the right, from your perspective, more to the right than instead of the left. Why that is, I haven't figured out quite yet. I'm thinking that maybe there are some deflection, permanent magnets on the neck of the tube, which are incorrectly set. Maybe the focusing magnets should be somehow reset or something like that. I don't know. I really don't know. So I will have a look at why the picture seems to be shifted slightly to the right instead of being exactly in the center. It's a weird phenomenon. I must say I don't know what causes it. If any of you have a suggestion as to why the picture is shifted more to the right from your point of view than to the left, please let me know, because for the moment I'm a little bit clueless as to what would be the reason for that. In any case, the TV seems to work just fine, and I had to tweak a little bit the vertical bias voltage, but mind you, just a little bit. And well, that's it for now. The next thing I'll be concentrating on is the cabinet of the TV, and of course reassembling everything. I used epoxy as a kind of bondo to fill up the spaces that weren't level with the actual cabinet of the Sony. But of course the problem with that is that when you fill up certain spaces with epoxy, the epoxy never flows out to be quite level with anything around it. So what I'm going to do is I'm going to use a very sharp little surgical knife to chip away the excess epoxy which is filling up the gaps. And when I've done that, I'm going to use relatively small grain sanding paper to sand off the rest until it's quite level with the original cabinet. I sanded for about 45 minutes and this is the result. And it's pretty smooth right now. And I tell you a little trick to know whether you sanded enough or not. If you look at the surface in which the repairs are mounted and you start to sand, you see that in this instance, for example, there was already a layer of paint. Now when you start to sand around a protrusion like these Bondo filled, or well, epoxy filled openings and metal filled, then you will see that as you start to sand, and I should say you have to really sand in every direction, so vertically, horizontally, diagonally, even around, yeah, and in both directions, so that you sand off really all the little edges and all that. Well, you'll see the paint or whatever was on the surface gradually move up to the spot you repaired. And when you start to see that the edge, let's say, of the original paint starts to get really light and really narrow, so that the gap is actually narrowing to your repair, then you can be almost certain you're getting very close to the point where your repair and the original base material are flush, really flush. So that's a good trick to remember if you're sanding and you're really wondering when to stop with sanding, because there is such a thing as over sanding. Okay, so if you sand really too much, you might create a new sort of depression in, well, for instance in metal, but the same thing applies to wood or copper or stone even. So once you start to get very close to the edge between the original material and your own repair, then you really have to start sanding carefully, slowly, methodically. Well, I think I'm getting very, very close to the point where I can say, okay, I sanded enough, and then I'm going to clean the cabinet with some alcohol, pure alcohol. I'm not going to go overboard cleaning it or sanding it. I'm just going to give it a very good wipe down with alcohol and water. Just plain simple tap water. And then I'm going to let it dry, completely dry, and then I'm going to give it a base coat. Okay, I gave the cabinet of the Sony a final very fine grit sanding. I think I used 1000 grit wet sanding to finish the repair off and make it completely smooth. Then I washed the cabinet in clear water, and finally I wiped it off with pure alcohol to remove all traces of grease. I then proceeded to tape off the back label, and now I'm going to give the cabinet a gray primer coating first, and when that is done, I'll give it a matte dark gray lacquer finish like the one you see here. Okay, the first layer of primer is sprayed on the cabinet. Now I'll wait to let it dry. Then I'll give it a very light sanding and give it a second coating of primer. And then when that one is dry, I'll spray the first and second layer of finishing lacquer. Well, the first lacquer layer is sprayed onto the cabinet, and the result is, well, reasonably good. And my choice of color seems to have worked out fine. This is actually quite close to the original dark dark gray that Sony must have used when painting the cabinet. So all in all, I'm reasonably pleased with the result. Now, this is the first lacquer layer. I will give it a second coating in a few minutes, and I think I'll leave it at that. I'm not going to use lacquer since the original paint job was a matte gray, and I want to keep it as close as possible to the original look. So that's it for now.